In today's video, we're going to take a look at the tree data structure, and we're going to start off with the linked lists actually. So if you haven't checked out, I suggest you go at the link above and take a look at what are linked lists. I have a playlist up there. Well, what was a linked list? Well, it was basically a data type that held some information, in our case, let's say a number, and a link to a pointer to the same data type, right? So in this case, is represented by this arrow, and here we have linked it to another element, right? And this is our linked list with 4 elements. That's perfectly fine. Now, why do I start with this? Because it's very simple to understand what is actually, or how a tree data structure looks like from a linked list perspective, right? As you might have noticed, for every single node that we have in the linked list, we have a single connection to another node in that linked list, which makes sense. It's just a simple linked list. But what happens if we, instead of have one descendant, one next node, we actually have 2? So let's say that instead of having just one pointer, I'm going to split this into 2, and we're going to have another arrow that comes out of it to another node. And let's change this to be a 5, of course. So tree data structure would look something like this, where you have nodes that can have 2 next nodes, 1 or none at all, right? And usually in literature, this is actually represented from a vertical perspective. So I'm going to take all of this, and let's see if I can rotate everything here. So something like this. And as with linked lists, this first node is the root node, and the rest are its descendants. And this is basically how we get a tree data structure. Now let's get on to coding. So what I have here is basically the data structure that we use to represent linked lists, right? And what we can do here is make a very simple modification to change this data structure to represent a tree data structure. By that I mean simply adding another connection, as we did in the diagram that I have showed you before. So we can change this, we can actually copy and paste this to say, oh, I don't know, let's say next 2 or something like that. Right? So that's going to be the second connection. And what we have created here is actually a node for a specific type of tree, namely a binary tree. Why is it a binary tree? It's simply a binary tree because it has only 2 descendants, right? So each node has only 2 descendants. In a generic tree, you can have as many descendants as you want. But for our purposes, we're going to actually talk about binary trees in the beginning, and we're going to expand over to more generic trees and then graphs later on. Now we can really leave the naming as is, but it's much easier to refer to as the first next node as left and the second next node as right, simply because in our diagram here, for example, what is the left descendant of the node 1? Well, that is 5, and the right descendant is 2, and that is quite easy to figure out, right, based on the diagram. So in the same idea, we have this this naming convention. Now, one more thing that I'm going to do is actually rename this to be called tree node, right? So I'm going to do something like this, and then let's do that to tree node. Simply because I don't want people to confuse the tree node that we're using with the node that we're using in the linked list. They are quite a bit different, and you're going to see later on that the algorithms for iterating, for searching, for modifying, for adding, for removing, for everything are quite a bit different than the ones for linked lists. But the basis for this data structure is there. So let's try to create a simple binary tree here with this data structure. You can say here tree node, and I'm going to allocate this on the heap. So I'm going to say I want a pointer, and I'm going to call it root. That's going to be the first element, and we're going to malloc. We're going to malloc with size of tree node here, right? And what do we have to do? Well, we have to initialize these 3 variables that we have in our root source. Root dash x, I'm going to say 0, so that's going to always be our root node of value 0. And let's also change this x variable because it might be easier to refer to it as val to represent the value itself, right? So I'm going to do that. Okay, now next is our left descendant of this root node. And for that, right now, I'm going to set it to null. right? We don't have anything else. And then for our right, I'm going to do exactly the same. So here we basically have a root node for our tree. So let's say we want to create a simple binary tree like this. So we just have that 0 root node, and we have on the left we have 1, and on the right we have 2. How do we do that? Well, again, we have to use malloc. So I'm gonna, instead of having here null, we're gonna say malloc of size of tree node, right? So exactly the same thing, and here the exact same idea. And well, how do we set the data for it? Well, here, since we assign to root and we set root arrow val to set the value, well, we can do the same here, say root arrow left arrow val to set the value, and here we're going to set it to 1. And again, we have to set the left and the right descendants of this to be null as well, right? Because in our little diagram we don't have anything after 1. So so the left, how do you read this? Basically, the left of the root node doesn't exist, right? And in our diagram you can see that that's correct. And similarly for the right ones, I'm going to just copy and paste this. I'm going to change this to a right, same thing here and same thing here. And of course we're going to change the value so that it's a 2. Right, now this is quite tedious, as you can see that at every addition of a new node we have to add basically 4 lines of code. Can't we just generalize this? And yes, we can by creating a pseudo constructor for this node. So we can just say here tree node pointer, let's say new node, let's call the function new node, and it's going to get in just a value, right? And what I'm going to do here is just say tree node, let's say n equals malloc of size of tree node, as I did before, and then n val equals the val that we have passed, and then I'm going to just set left to be null, and n right to be also null. And at the end I'm going to actually return this n that we have allocated dynamically. And now all we have to do, instead of doing all of this, we can simply say tree node of left equals new node of 1, right? And right equals new node of 2, right? And we no longer need to do all this because this has been already done for us. And then we can say left here and right here. And that kind of simplifies things. And I'm gonna actually simplify it a little bit further because I just want the initialization of the tree to be as simple as possible. So I'm gonna change this to be new node of 1, and this is gonna be new node of 2. And then we no longer need even variables, we can just do something like this, and there we go, we have already initialized everything. We can even do the same for the root node. We can just say new node of 0, and now we no longer need to initialize the var. The left and the right variables we have to actually initialize to 1 and 2, of course, because we need to make that link. And if we check that if this compiles, indeed this does compile, but we're not printing anything. So let's just try to print a few things here. So I'm going to say printf, and let's say root value is %d. All right, what is the root value? Well, in our case, it should be root arrow var. That's where we should find the root value. That's pretty self-explanatory. Now let's copy and let's change this to be, let's say here, left descendant of root is %d. And I forgot here some backslash n, let me just do that. And here this is going to be different. It's going to be what? Well, we have the root, of course, that's the only thing that we can access, but we're going to go into the left node and dereference that and get the value out of it, right? And very similar for the right one. I'm just going to say right descendant, and here we can change this to be right. And here, if we try to launch this, we're going to say that the root value is 0, the left is 1, and the right is 2. So that worked perfectly fine. Now, for now, we're not going to worry about deallocating the tree, right? You can actually create very simple deallocation here with just free calls, but I'm not going to worry about it. Later on, we're going to see how to actually deallocate the whole binary tree using a function. We're going to take a look at that in a later episode. But hold on a second, why are we even learning about this data structure? Doesn't it seem quite complex and esoteric? Yes, but it is actually incredibly useful. For example, the tree data structure is used in databases for indexing, and searching, modifying, deleting, or doing a lot of the operations that are normally used in a database are orders of magnitude faster using a tree data structure than without. Similarly, this method of indexing is used for your file system as well, so that things can be much faster accessed. And the use cases doesn't even end there. We can use this data structure to implement certain algorithms in artificial intelligence. Sure, some basic ones, but it's incredibly useful. Other use cases include routing of data, routing of, well, people. Think about Google Maps, for example. And even in your compiler, you have something called a syntax tree, which is literally a tree data structure for the compiler to understand what is going on inside your program so that it can translate it down to assembly and later on to machine code. So this data structure actually has a lot of uses, and it has some of the most complex algorithms that I think you and I can think about. And it is important to know which algorithms to apply when with these data structures, and this is what we're going to take a look at in this this series of videos that I'm going to release over these couple months. For now, I hope you got something out of this video. If you do have any questions, leave them down in comments below or on our Discord server. Again, the source code can be found on our website down below in the description. Take care. Bye.